Okay, this is a film about a number of theories or theorems about circles, called collectively circle theorems. And the first one is about the radius of a circle from the center to the edge, and a tangent. A tangent is a point that just touches a curve at one point. So this is a tangent to the circle at this point here that I'm pointing to, because it just touches the circle at that point. And the first theorem is that a radius to a circle and a tangent that just touches the circle at the same point that the radius goes out to, they meet each other at 90 degrees. Okay, here's the second one. The angle at the center is twice the angle at the circumference. What that means is, if you take 2 points on the edge, like these two here that I'm pointing to, and then you join them up at the center, then they make an angle here that I'm pointing to at the center, and then you join them up again from the 2 points to another point on the other side, at the circumference in other words, the edge of the circle, then that angle in the middle is twice as big as this angle on the edge, the angle at the circumference. So it's got to come from the same 2 points, an angle at the center from those 2 points, and an angle at the circumference from those 2 points. And the one in the middle is twice as big as the one on the edge. So for example, or generally, if that's x on the edge, then the one in the middle will be twice as big, 2x. And that can appear in several different forms. For example, here, it looks a bit different, but it's the same basic rule, because you've got 2 points on the edge, an angle at the center, and from the same 2 points, an angle at the circumference. So that angle in the middle will still be twice as big as the angle at the edge. Again there, even though it crosses over, so it looks different still, it's 2 points making an angle at the center and an angle at the edge, at the circumference. So this angle at the middle, at the center, will be twice as big as this angle here on the edge at the circumference. Number 3, angles in the same segment are equal. Well, if we start with a line there, a chord, from one point on the edge of a circle to another point, then we can form an angle at the circumference, like we did previously, from those 2 points over at the other side. Now we can do that there, or from those 2 points we can do it there, or we can form lots of angles from those 2 points over at the other side. And the point is that all of those angles that I've marked in yellow, providing they come from the same 2 points, are equal to each other. So all of these yellow angles are equal to one another. And here's an example of that in practice. So it looks a bit different because I haven't drawn lines across, but you've got 2 points here, one there that I'm pointing out and another one there that I'm pointing out, and they've been joined up at the other side to an angle of 48 there. Now the same 2 points, that one there and that one there, have been joined up to make that angle there. And because they come from the same 2 points, then that angle there is 48 degrees as well. Now this question here, the point is to find out what x is in the middle there. So let's just think about what we just said. Those two angles are the same, those two yellow ones, because they come from those 2 points. So they're both 48 degrees. And in this triangle here, Well, we know that a triangle must add up to 180 degrees. So if x plus 48 plus 50 makes 180, we should be able to work out what x is, and it's 82. Number 4, the angle in a semicircle is always 90 degrees. So again, we've basically got 2 points on the edge joining up to make an angle on the other side. But this time, the 2 points on the edge, if you join them up, they go through the center of the circle. So they cut the circle in half. So they cut the circle into 2 semicircles, in other words. So when your 2 points are exactly on opposite sides of the circle through the center, then that angle on the other side is 90 degrees. So wherever you put that angle, as long as they come from those 2 points, then that angle on the other side will be 90 degrees. Number 5, opposite angles in a cyclic quadrilateral always add up to 180 degrees. Well, first of all, we should say what a cyclic quadrilateral is. A quadrilateral is any 4-sided shape. So that's a 4-sided shape. And a cyclic quadrilateral is one where all 4 corners, or vertices, to use the proper mathematical word, lie on the edge of a circle. And this rule says that the opposite angles add up to 180 degrees. So A plus C, the 2 red ones, add up to 180, and B plus D, the 2 yellow ones, add up to 180. So for example, if that's 125, then the other one's 55. If that one's 72, then that one's 108, because 72 plus 108 is 180, and 55 plus 125 is 180. Now, here is an exam type question that often occurs, and it's a tricky one because it looks like a cyclic quadrilateral because it's a 4-sided shape inside a circle, but only 3 of the sides, 1, 2, 3, are actually on the edge of a circle. The other side is not on the edge. So it's not a cyclic quadrilateral. The opposite angles don't add up to 180 in this. And in fact, what this is the other rule that we saw about angles at the center and circumference. If we look at these 2 points here, they make an angle of 108 at the circumference. They also make an angle at the center. Now if we go back a few steps in this show, we had the rule that the angle at the center is twice the angle at the circumference. Now this rule applies here. But in this case, the angle at the center is this one here, that's on the other side of x, and that's twice the 108 because they both come from these same 2 points. So that's 216, the big angle on the other side of x, because it's twice 108, and then x here is what's left over at the center of the circle, which is 164, because all of the way around the circle adds up to 360. Okay, number 6. The angle between a circle and a tangent is equal to the angle in the alternate segment.